Before looking at the distributive property, I put the definition of a term and like terms up here, but if you've worked with algebraic expressions before, terms are just separated by plus or minus signs. Like 15x is a term, so is 45x squared and 2y. Even 5 at the very end could be considered a term as well. So we have a total of 6 terms in this expression. A like term means that the variables are exactly the same, even though the coefficients, the numbers in front of the variables, could be different. So if we look at this a little bit more carefully, starting with 15x, so here, I see that I have another x that appears over here, so 15x and 3x are like terms. Anytime that you have like terms in an expression, it means that you can combine them. So 15x and 3x, we could really put together and have 18x. If we do this for everything that remains, I have this 45x squared y, not the same as this, it's not the same as this, but okay, here we have x squared y's again. So we've encountered more like terms. So the 45x squared y and this 0.5x squared y. I can subtract the coefficients in front of them, and that gives us 44.5 x squared y. The remaining stuff would be this 2y and this 5, but they're not similar or comparable with anything else, so I'll just put them at the very end. And that's everything I wanted to say about terms, and more specifically, like terms. Moving on to the distributive property, which is listed right here, this gives us a way to multiply a term into a set of parentheses. So a times b plus c is the same thing as ab plus ac. It's called the distributive property because a gets multiplied to b, and it also gets multiplied to c. Let's check this out in example 1. So being really careful here, we have x times 1 plus 5x. To multiply these together, x gets multiplied to 1, so that's x times 1, but then x gets multiplied to 5x as well. And we'll have to use some of our rules of exponents, but starting with x times 1, I'll just call that x, and then we have x times 5 times x. I'm going to write that as plus 5, and x times x is x squared. Here I distributed x into the parentheses. I look at this answer, and these are not like terms, so I can't simplify it any further, and that is the answer for this first part. Let's try this again in negative 2x squared multiplied into 4x minus x cubed. This is negative 2x squared times 4x. Okay, here I have this negative times a negative. Since I have this negative, I'm going to switch it to a positive, like kind of as a little shortcut here. So the negatives are gone, and I'm left with my 2x squared being multiplied to x cubed. A negative outside of the parentheses will change the sign on everything inside of it. This first one was positive, it's now negative. The second one was negative, it's now positive. If I combine these together, I get negative. 2 and 4 gives me 8. X squared and x gives me x cubed. Then it's going to be plus. I have 2 times a 1, so that's just 2. And x squared times x cubed is x to the 5th. Again, I look at this expression and I don't have like terms. That means negative 8x cubed plus 2x to the 5th is my final answer. And for example 2, I want to multiply these out, just trying out a few more complicated examples. So for this very first one, I'm seeing that the outside is negative, so I know the sign is going to change on each term inside the parentheses. Keeping that in mind, I have negative 0.5 xy times 10x. So this whole thing gets multiplied here. It's going to be negative, and 0.5 times 10 is 5. I have x times x, which is x squared. And then I have y. There are no y's here, so it just tags along to give me x squared y. I now distribute this negative 0.5 xy to 20y. Okay, again, the sign changes, so it's going to be negative. Okay, 0.5 times 20 is going to be 10. I have x, but there are no x's here, so I'm just going to copy down that x. And this time, I have y times y, which is y squared. Okay, I have 2 terms remaining to distribute to. I have to multiply this to this negative 3x cubed. Okay, so now we're going to get something that's positive. A negative times a negative is a positive. 0.5 times 3, that's 1.5. Just use a decimal. I have x cubed times x, that's x to the 4th. And then y again tags along. And for my last step, distributing this to the negative 14, it's going to be positive. I have 7 and an x and a y. I'm scanning across each term. I do not see any like terms in my answer, and this mess, this whole thing is my final answer after I multiplied negative 0.5xy into the parentheses. All right, let's try this now on the very last one here. All right, so I have 2 sets of parentheses, and this means I'm going to use the distributive property twice. So first, I'm going to take this 2, multiply it here, combine any like terms, and then I'll distribute this y last. So let's try this out. So I'm leaving that y outside the bracket alone, and I have this y, now I have a plus 2. This 2 is being multiplied to 1, 3x, and 5y. It's a positive 2, which means the sign is not going to change on each term. 2 times 1 is 2. 2 times a negative 3x is a negative 6x. And 2 times 5y is plus 10y. My second step would be to multiply now this y into this set of parentheses, but I see there's a y and a 10y. I'm going to combine like terms first. So I have 2, I have minus 6x, I have a 1y here, a 10y here, that's a total of 11y. I no longer have any like terms to combine, so I can now distribute this y into the parentheses. It's a positive y, meaning I'm not changing the sign. I get 2y, I get minus 6xy, and plus 11y squared. And that is the answer to this last part.